I am Thibault Martinez, software engineer at the IOTA Foundation, and I am very excited to speak about B today. As you may know, Chrysalis is the biggest update on the IOTA protocol so far, and B is a major component of it. So what is B exactly? B is part of the Foundation effort to move most of our code base to the Rust language. We have been doing this on most of our new projects, including our permanent solution, our new node implementation, IOTA streams, IOTA identity, our wallet abstraction, or Stronghold. This is basically a completely new way for the community to interact with the IOTA protocol. For developers, we want to give a unified approach and clear guidance by providing safe, audited, and easy-to-use fundamental blocks. And for node operators, we want to give a new node implementation. So why a second node implementation? At the moment, IOTA networks rely on the Hornet project, which is a community-driven node implementation written in the Go language. While the Hornet team has been doing an amazing work with this node, this can still be seen as a single point of failure in the network. If a major issue was found in this node, there could be a risk of general outage of the network. By having a second node implementation by a different team in a different language, we drastically reduce this risk. Having two nodes also helps improving the quality of both node implementation by mutual error discovery. For example, Hornet discovering issues in the B node and B node discovering issue in the Hornet node. One could argue that this is not absolutely mandatory to have two nodes implementation right now, because the coordinator is here to prevent major issues happening to the ledger state. But we are also preparing for coordicide, where errors without a coordinator could have huge consequences. So having two nodes implementation overall gives more confidence to all involved parties. Why was Rust chosen for the B project? Rust provides a lot of advantages that helps make the B node safer and more efficient. Rust is fast. It's probably the fastest portable general-purpose programming language. It also comes with a lot of guarantees at compilation time, meaning that it's a bit more annoying to make compile, but when it does, you know that it will run just fine. Rust is memory safe. As an example, both Microsoft and Google reported that 70% of their software crashes were memory related, and that's a whole range of errors that just doesn't exist in safe Rust. Rust has a very powerful and strict type system, enforcing that APIs you write are going to be correctly used. It has a strong ecosystem of battle-tested crates and a dependency management tool that makes development really convenient. It doesn't have garbage collection, and that's very useful when we want the node to be responsive and the network to be low latency. It forces developers to acknowledge and act on errors. Unlike other languages, Rust won't let you easily get away with unhandled errors. It has a powerful thread system and generics that allows for building modular architectures. It comes with integrated tests, benchmarking, and documentation tools. And finally, Rust RFC process and monthly release cycle make it really easy for everyone to improve the language. These are some examples of the Rust advantages, and all of that makes that Rust has been the most liked programming languages for the past 5 years on the Stack Overflow development survey. We can also see that more and more companies are either starting to completely build on top of Rust, or providing bindings or client libraries, or even investing to improve the language. At the B team, we are very happy working with Rust on a daily basis, as we think it makes us better programmers. So first thing first, if you want to read some B code or have a look at our issues and see what we are doing on a weekly basis on our Kanban project board, you can go to the B repository on the IOTA ledger page on GitHub. When I'm shooting this video, The default branch is Chrysalis part 2, but when it will be released, it's probably going to be changed to the dev branch. The way we tried to organize these repositories by having many different crates that each have a specific purpose. For example, if you are interested in the way the ledger state is processed, there is a bledger crate. If you want to see the details of the message layout, the milestone layout, the input, output layouts, we have a bmessage crate for that. So I'm not going to detail the content of each crate. The name is pretty self-explanatory of what they are containing. So yeah, if you want to read some B code, it should be very easy to understand where what you are looking for is. But one that is very important is the bnode crate. It actually contains the bnode binary. So let's have a look at this one. In this one, there is a README on how to install B from source. We are still in alpha, so we are not yet publishing binaries, built binaries of B. So if you want to use B at the moment, you have to compile it yourself. I'm not going to do that as part of this video because it takes a while in Rust. So, but yeah, the steps are pretty clear on how to do that. Depending on if you are on Debian, macOS or Windows, we give you a list of dependencies to install. If you haven't installed Rust yet, we tell you how to do that. And finally, we tell you how to compile the bnode and how to run it. All right. Then let's have a look at the bnode running. Here I have two different nodes. They are both connected to the same AlphaNet. The first one, this one, is connected to 5 community nodes, and this one is connected only to the other one. You can see if you are used to running an Hornet node, it shouldn't be too different. The logs are pretty similar. You can see some MPS reports, so incoming messages, new messages, known messages, invalid messages, and outgoing messages. From time to time, you have a new milestone incoming, and right after you have the confirmation log of this milestone. And you can see that this node is synchronized at the moment. And every minute or so, there is some metrics that are being logged as well. We can also have a look at the dashboard of this node. If you already run an Hornet node during Chrysalis, you may recognize this dashboard. We have a common dashboard for the bnode and the Hornet node so that it's identical and that node operators know exactly how to use it. So this is the home page. Lots of information that we can quickly go through. There is a search bar when you can look for basically everything in the Tango. So addresses, milestone, messages, outputs. We'll have an example later. Then we have two lights to indicate the health and the sync status of this node. Then we have the message per second metric. We have some memory metrics, the database size, and the consumed RAM. Then in this card, we have the alias of the node that you set yourself. Then we have the peer ID of the node. We'll speak about that in a bit. Then we have the network ID in which this node is operating. And then we have the version of this node. Then here we have the synchronization status. So we have the latest solid milestone index and the latest milestone index. Then we have the pruning index. We have the uptime and we have the consumed RAM. Here we have a list of peers. We only have one peer at the moment, as I said. If we go to the analytics, we have some more data, some more live data that you can see are being updated. At the moment of recording of this video, not everything has been filled in the dashboard. You can see that there are some missing data. I think by the time this video is published, everything should be there. Here you have an overview all of the peers. as I said, there is only one peer. If we click on more details, we have more detail on this specific peer. Then you have the Explorer, you have a live feed of the latest milestone. If we click on a milestone, we have more information about this milestone. We can click on the parents of this milestone. We have information. We can see that this one contains an indexation payload. We have the data of the payload. What we can do, for example, is to copy paste the ID of this message, go back to the home page and do a search in the Tango, and we should go back to the same page. Then we have the visualizer that gives a visual representation of the Tango. And we have some settings. At the moment you can only change the theme to light or dark. We'll probably come back to the dashboard in a bit. Alright, so something else you can do with the B node is to use the CLI tools. And this is very interesting for debugging purposes. So let's see what the B node can do. Alright, so we have a list of subcommands. You can see that, for example, we have ed25 that helps you generate ed25 public-private key pairs. So let's try this one. Keys, oops. And it gives you a private key and a public key that you can later use. We also have, for example, snapshot info. This one is interesting to get some information for a specific file. For example, this one. And it gives you everything you need to know on a specific snapshot. What else? We have RocksDB. At the moment, the B node use RocksDB as a storage backend, and not everything is being exposed by the REST API. Some data you may need to have access to, and you can't go through the API. So we developed this RocksDB tool to have a direct access to the data. So let's have an example. Alright, so RocksDB, it takes as first parameter the storage folder, then it takes a column family or table. This one is address to balance, so this is the mapping between addresses and their balance. And what we are going to do first is a streaming operation. So we are basically going to stream all of the key pairs. And then we can see that the keys are ed25 addresses, and we have the balance. If we want to only select one, we can also do a fetch operation, for example, like this, and we get back this specific entry. And you can fetch and stream basically all column families. All right, and the last subcommand that we can use is the peer-to-peer identity. So let's see what it does. It generates for you a private key, a public key, and a peer ID. We are going to speak about that right now, but with Chrysalis, with the Chrysalis release, the network stack has been completely refactored, and it now used something that is called peer ID to peer between the nodes. But let's see what it looks like. To run the B node, you need a configuration file. For the B node, this is in the TOML format, which is the standard in the Rust ecosystem. So it looks like that. I am not going to detail all of the variables because most of them have default values and they are fine to start with, but things that you absolutely need to change are in the peering section. But let's start with the alias. The alias is the name you want to give to your node. It's very useful if you are operating many nodes at the same time, and this is what appears there in the dashboard. and you have the network ID as well in which you want to operate. Then you have logger output. You have one default output that is the standard output in info level, which is what's happening right now in the node. But you can add as many outputs as you want with the level you want. So you could do something like that. warn.txt in the warn level. And that would log all warnings in a warn.txt file. Then you have to fill the peering section. When you start with the bnode, this would be empty and you have to fill it with a value. And this is what the peer-to-peer identity command gives you. So you have to save this one, the first one, the private key, and put it in this field. And based on that, the node would generate a peer ID that would appear there in the dashboard. And this peer ID is what you need to give your peers if you want to pair with them. Here is an example. And you can see that for each peer you have to provide an address and an alias. The alias is what would appear here. And the address, if you are not used to Chrysalis yet, this is what's called a multi-ADDR. And it's basically a way to have a flexible address. So you can encode many information in the same format. For example, it starts with DNS right now, but you could also use IPv4, and instead of a DNS you would put an IPv4. You can also put IP6 and you would follow it by an IPv6. Then there is the TCP port that is being used. You could change that also to UDP, but we don't support that at the moment. And then there is the port. You can obviously change the port, and then you have P2P and the peer ID, and the peer ID is this one. So you have to give this one to your peers so that they can put it there. And this is how you add peers. Everything else has default values, as I said, and they are ready to use. So you don't really need to change anything. Alright, what we could show is some API calls. So I prepared some of them. Let's start with a very simple one. With this one you can get back some information about the node. So you can have the name, the version, if the node is healthy, in which network it's operating, the latest milestone index and solid milestone index. If you want to have access to all the API endpoints, you can go to the protocol RFCs repository and go to pull request, and there is the REST node API pull request. Maybe when you watch this video it's been merged, so this would be in text, but at the moment it's still there. And you can click on rendered, and then you have access to all of the endpoints. So there are like maybe 18 or 20 endpoints, so I'm definitely not going to show them all, but some of them. So another one that is useful for clients when they want to publish a message, they need to get some tips. So this looks like that, /v1/tips, and then you have access to some tips. Another one, very interesting, is to have access to a specific message. So /messages and then the message ID. And we get all of the information about this specific message. We have type 1, and type 1 is a milestone, so this message is milestone. So basically you have the milestone payload there. So you have the Merkle proof, you have the public keys and the signature of this milestone. With basically the same endpoint, by adding metadata, you have access to the message metadata. So you have the solidity flag, you have the parent message IDs, you have the ledger inclusion state and some information. And with a very similar endpoint as well, you have access to the children of this specific message. Another one very interesting is to have access to the balance of a specific address. So what is to be noted here is that we are using a base32 format as input. It basically allows us to encode many different address types in a similar format. But you can see that the API gives back the same address but in hexadecimal, and we have the balance of this address. To verify that, we can use the dashboard, for example. So I go back to the home page, I input the address, and then I have the same balance. I used the hexadecimal version of it, but I can also use the base32 version of it, and I would have the exact same output. Alright, so that was some example of the API, and that's the B node running. So nothing very fundamentally different from the ordnet node. The REST API is obviously the same because that's standard. And yeah, I think that was a quick overview of it. And if you have some questions or suggestions or anything, we are on Discord and ready to answer your questions. If you are interested in either IOTA or Rust, I invite you to join our Discord server. The B team is very active, working there on a daily basis. Everything is very transparent and we try to answer community questions as much as possible. We also do weekly live streams on YouTube, and we will soon do impromptu live streams on Discord as well. We publish weekly digests and meeting reports so that everyone can keep track of the progress of the B team. Our issues and Scrum Kanban board are also available on our repository if you want to contribute to the project.